Hi everyone. In our last lecture, we have gone through a brief introduction about ordinary differential equations and their solutions. In today's lecture onwards, we will be seeing different methods for solving first order ordinary differential equations. The first method is separable equations. Separable equations is one of the methods to solve a first order ordinary differential equation, that is first order ODE. First, we will see what a separable equation is. A first order linear ODE is said to be separable if we can separate the variables, that is, the independent variables and dependent variables. In most cases, dependent variable will be y and independent variable will be x. So, an equation will be separable if we can separate the variables x and y in such a way that all the terms in y comes to one side of the equal to and all the terms in x comes to other side of the equal to side. For example, here the equation dy by dx equal to xy. It is separable because we can bring all the y terms to one side and all the x terms to other side as dy by y equal to x dx. Whereas this equation dy by dx equal to x square plus y square is not separable since we can't separate the terms y and x in such a way that all the y terms are in one side of equal sign and all x terms are in the other side of the equal sign. Next, we will use this method, that is separable equations, to solve a first order ODE. Here we are given a first order ODE y dash equal to 2xy. Here y dash is dy by dx. So first we will write this equation as dy by dx equal to 2xy. Now we will separate the terms in y and x. Separating y and x, we will get, that is, we can bring this y to this side and dx to the right side. So we will get dy by y equal to 2x dx. Once we have separated the variables, we can integrate both sides. So here we will be integrating both sides. That is, we get integral dy by y equal to integral 2x dx. We know that integral of 1 by y is log y and integral of x is x square. So simplifying, we get log y equal to x square plus c. This can be taken as the final answer. But still, if we want the answer as y equal to a function of x, then we can do further simplification. For that, we will take exponential on both sides. Since log and exponential are inverse functions, they will get cancelled, and on LHS we will get y, and on RHS we will get e raised to x square plus c. This is the solution. Now we can further simplify the solution as we have got the solution as y equal to e raised to x square plus c. We can further simplify it. That is, splitting this, we get e raised to x square into e raised to c. And e raised to c itself is a constant which can be taken as capital C. So we can write this solution as y equal to c e raised to x square also. Now we will do another problem. The ordinary differential equation given is xy dash equal to 1 minus 2x square into tan y. First of all, we will write y dash as dy by dx and we will get this equation, that is x into dy by dx equal to 1 minus 2x square into tan y. Now we will separate the variables, that is, we will bring all the y terms to one side of equal sign and all the x terms to other side. Bringing all the y terms to left hand side, we get 1 by tan y dy equal to 1 minus 2x square whole by x dx. Now 1 by tan y is cot y and this can be simplified as 1 by x minus 2x. Once we have separated the variables, we will integrate both sides. So here we will integrate both sides and we will get integral cot y dy equal to integral 1 by x minus 2x dx. We know that the integral of cot y is log sin y. Integral of 1 by x is log x and integral of x is x square by 2. So simplifying, we get log sin y equal to log x minus x square plus c. we can stop here. But if we need answer as y equal to a function in x, we can do further simplifications as we will take e on both sides. Since e and log are inverse functions, they will get cancelled, and we get on LHS we get sin y, and on RHS we get e raised to this thing, that is e raised to log x minus x square plus c. Now we can split this as e raised to log x, e raised to minus x square, e raised to c. Again, since e and log are inverse functions, they will get cancelled, and here we will get x into e raised to minus x square into e raised to c. Again, e raised to c is a constant. It can be taken as capital C, and we get sin y equal to capital C into x into e raised to minus x square. Again, this sign can be brought this side and it will become sine inverse. So, the final answer is y equal to sine inverse of cx e raised to x square. Thank you.